Hello and welcome to this next lesson looking at antimicrobial resistance. So today's title is Antimicrobial Resistance. You need to write in your exercise books, please. By the end of this lesson, you should be able to recall the bacteria that develop resistance to antibiotics is evidence for evolution. You should be able to explain how antibiotic-resistant bacteria develop, and you should be able to evaluate how the development of antibiotic-resistant bacteria affects how disease is treated. So, antibiotics have saved countless lives since they were invented, okay? Antibiotics were widely used during World War II, but within 4 years of them being used in 1947, some bacteria had become resistant to the penicillin being used. So we can start by saying that penicillin, P-E-N-I-C-I-L-L-I-N, penicillin was first used in 1943 to treat those in World War II. Those in World War II. Okay? We can also say that by 1947, the bacteria that was treated using penicillin had become resistant. So we can say by 1947, bacteria had become resistant to the penicillin so it could no longer be used to treat disease. So it could no longer be used to treat disease or treat these diseases or these bacteria, we'll say. So the point I'm trying to make is that penicillin is a type of antibiotic that had been used in 1943 to treat diseases. However, by 1947, the bacteria which were treated using this penicillin became resistant to that penicillin being used. Now, the sad news is that bacteria and other microorganisms are always becoming resistant to drugs that we have made to kill them. So I'm going to put in red, because everything that I put in my lesson in red is a very important point. We can say that bacteria and other microorganisms are becoming resistant to the drugs designed to kill them, that have been designed to kill them. Okay? So lots of microorganisms are starting to become resistant to the drugs that have been designed to kill them. Now, this is usually caused, or is caused, by mutations in the genes of these microorganisms. And in particular, this happens in bacteria. So we can say that mutations in the genes of pathogenic bacteria produces new strains dot dot, some of which would be resistant to an antibiotic used on a patient. Some of which may be resistant to antibiotics used on a patient. To antibiotics used on a patient. Okay? Now we can think of this by modeling it with a flow diagram. Okay? So I want you to imagine that we've got a population of bacteria. So this is my population of bacteria drawn with blue dots. So this is a population of bacteria in blue. And I want you to imagine that one of these bacteria have got a mutation, which I'm going to put in this red colour so that it stands out. Okay? So we can say underneath these that it is a population of bacteria where one bacteria has a mutation making it antibiotic resistant. Making it antibiotic resistant. So I'm going to put AR to shorten it. So we've got a population of bacteria where one is antibiotic resistant. Now, if you happen to have all of these bacteria inside of your body, you would be very ill, and therefore you would go to the doctors. If you go to the doctors, what will happen is the doctor will give you antibiotics to treat the bacterial infection. So you will have antibiotic treatment. Antibiotic treatment. And what this will do is it'll kill all of the bacteria apart from the one that is resistant. So the mutated bacteria will survive and it will have all of the space, all of the nutrients, everything it needs to itself. It's no longer competing with these bacteria. Chances are, if you didn't take the antibiotics, this mutated bacteria would be killed off because it would be out-competed for resources by the other bacteria. But because you've got rid of all this competition by taking antibiotics, this bacteria now has all of the resources it needs to survive. So we can say underneath here that the mutated bacteria mutated bacteria survives and has all of the resources to itself, and has all resources to itself. Now, a few lessons ago, we looked at this, and this is a process known as natural selection. Natural selection. So natural selection takes place, killing all of the non-antibiotic resistant bacteria, whilst the other one survives. Now, bacteria divide by a process known as binary fission. And what that means is that one bacteria becomes 2, 2 becomes 4, 4 becomes 8, and so on and so forth. Bacteria divide every 20 minutes. So while this one mutated bacteria is by itself and it has all the resources it needs to survive, it will then undergo binary, B-I-N-A-R-Y, fission, F-I-S-S-I-O-N, binary fission. And when it does this, it makes exact copies of itself. So rather than having one bacteria with the mutation, you'll now have lots of bacteria with the mutation. Okay? So we can say that the mutated bacteria uses all of the resources to reproduce and make a population of bacteria that is antibiotic resistant. Okay. So we've started with a population of bacteria where one of them has a mutation. If we left this population by itself, the one with the mutation would probably die out because the other bacteria would get the resources before it can, and it wouldn't have the resources it needs to survive. It may not have nutrients, it might not have space. However, by using antibiotics, we wipe out all of this competition, leaving the mutated bacteria behind on its own. This mutated bacteria would then have all of the resources it needs to survive. This is known as natural selection. It had all of its competition wiped out. So this bacteria, having all the resources it needs to survive, will undergo binary fission to form a population of bacteria that all have the mutation. They are all antibiotic resistant. So these bacteria will not have antibiotics work on them. So we can say next to this that the antibiotics this population is resistant to will not work on them. Okay. Now, if we think of the soldiers with penicillin back in World War II, the soldiers would have come back from the war with lots of bacterial infections. They would have had a population of bacteria in them like this. There may have been one bacteria out of the millions and millions and millions that were inside their bodies that were antibiotic resistant. They had a mutation. When doctors gave them the penicillin, it would have wiped out all of the bacteria except for the mutated ones, which would then have all of the resources inside of the body of the soldier to themselves and would have then gone through a binary fission to form a population of bacteria that no longer are affected by penicillin, and penicillin would no longer work as a result. Okay? Now, this isn't something that's make-believe, okay? This is something that's happening right now in our everyday lives. Now, Staphylococcus aureus is a type of bacteria that is building up resistance to antibiotics. This forms something called methicillin-resistant Staphylococcus aureus, or MRSA. Okay? So Staphylococcus, Staphylo, COCCUS, Staphylococcus aureus, AUREUS, a building up, or we'll just say, are a bacteria that are building up resistance to antibiotics to form MRSA. Now, MRSA is of a particular problem. People, when I was your age, when I was 16, the hospitals were facing a big issue with this. People were going into hospital to have treatment on infections and ending up catching MRSA. And as a result, they were losing limbs. Okay? Now, the problem is because antibiotic resistance is built one by one. If one antibiotic doesn't work, another one has to be used, and eventually the bacteria becomes resistant to those ones, and in which case we have to use another one and another one, and eventually we run out of antibiotics that we can use. So we can say that if one antibiotic doesn't work, on a bacteria, another one has to be used. Full stop. Eventually, we will run out of antibiotics that work. So eventually, we will run out of antibiotics that work. Okay? So essentially, the more antibiotics we use, the more we're going to struggle to treat these sort of illnesses. Now, this phenomenon is a key word for today. It is known as antimicrobial resistance, or AMR. So, antimicrobial resistance. or for short, AMR. AMR can be defined, and it has got quite a long definition, as an increasing problem whereby bacteria have evolved to develop resistance to antibiotics due to their overuse. So antimicrobial resistance is an increasing problem whereby bacteria have evolved to develop resistance to antibiotics due to their overuse. So how can we combat AMR? So we can put the subheading, combating antimicrobial resistance. Combating antimicrobial resistance. The first thing is taking the entire course of antibiotics prescribed. So taking the entire course of antibiotics prescribed. Now this seems like a bit of a sort of it seems like against what we should be doing. This is because it says there it's due to their overuse, but the first step in combating it is to make sure that we use all of the antibiotics that we've been prescribed. Now, ultimately, if we don't use all of the antibiotics that we're prescribed, any bacteria left by not completing the course will be more resistant to antibiotics than the other ones that were killed. So the ones that are left behind at the end of the treatment have more resistance to antibiotics than the ones that were killed at the beginning, and therefore it's best to make sure that they are killed as well. So we can put that, I'll just put underneath here, because this is the only one we're really going to elaborate on. We can say that bacteria left at the start, at the end even, at the end of treatment have the most resistance, have the most antibiotic resistance. Okay, so it's best to take the full course, which will kill them. So taking the full course will kill them. Now, what we mean by this is if you are prescribed antibiotics to take by your doctor, a lot of people will feel better within a couple of days, and what they'll do is they'll go, oh, I won't take the rest of them tablets, I'll just flush them down the toilet or put them in the drawer for use if I get ill again. That is the worst thing you can do. Even if you feel better after 3 days, you should take the antibiotics for the next 2 weeks or however long your doctor has asked you to take them for. Okay? This way it ensures that all of the antibiotic resistant bacteria are killed, or at least the majority of them. You should never share antibiotics. Never share antibiotics. If your friend is ill or a family member is ill, you should always make sure they go and see a doctor. Antibiotics should only be given by a doctor. At the same time, doctors shouldn't give antibiotics out too much. So we can say that doctors should not over prescribe antibiotics. So doctors shouldn't just give out antibiotics willy-nilly. They should just only give them when they're really needed. You should only use antibiotics on bacterial infections. So only prescribe antibiotics for bacterial infections. Remember, antibiotics only work on bacteria, they don't work on viruses. We should reduce the amount of antibiotics used in farming. Now, essentially, when you farm animals in a battery farm, the cages are kept very close together, and if one chicken or one cow or one sheep gets ill, 9 times out of 10 it's passed to the ones next to them. As a result, farmers give their livestock antibiotics to ensure that they don't get ill. When you then eat those animals, that goes into you. So we can say reduce antibiotic use in farming. So reduce antibiotic use in farming. And finally, we need to encourage drug companies to make more antibiotics. At the moment, drug companies are looking for treatments for things like cancer and heart disease and diabetes. They're not focusing on antibiotics, and as a result, we're running out of them. So encourage drug companies to develop new antibiotics. Right then. So MRSA is an antibiotic-resistant form of Staphylococcus aureus. Usually, if one antibiotic stops working on bacteria, we start using different ones, and eventually we will run out of antibiotics that we can use. Antimicrobial resistance, or AMR, is an increasing problem whereby bacteria have evolved to develop resistance to antibiotics due to their overuse. Combating antimicrobial resistance, we can ensure that we take the entire course of antibiotics prescribed. We never share antibiotics. Doctors should only prescribe antibiotics if they're really needed. Only prescribe antibiotics for bacterial infections. Reduce antibiotic use in farming. And encourage drug companies to develop new antibiotics. So by now you should be able to recall the bacteria developing antibiotic resistance is an example of evolution. You should be able to explain how antibiotic resistant bacteria develop, and you should be able to evaluate how the development of antibiotic resistant bacteria affects how disease is treated. If you have any questions about this lesson, please do not hesitate to contact me via the usual means. If not, I will see you in the next video. Thank you very much.